So, good morning.
Good morning.
So I'm going to be recording this lecture. I will upload it to the YouTube, and you will just rewatch it if you will feel that you needed something to review. So it will be available there. So what we're going to do today, we're going to go again through the VAR model, but
This time monthly, right?
no, this time yearly again, because I'm going to give you the exam on yearly basis. But the matter is to understand what stands behind the result that you're going to be getting. Okay. Sorry? Yeah, Zoom too. Zoom. It's already on Zoom. Oh, it's not open. My bad. So again, next week we're gonna have the quiz. The quiz will be on Tuesday, and the exam gonna be on Thursday. The quiz will include only the VAR model, but the exam will include everything, whatever we have done so far. Okay, now I'm gonna open this data. Okay, here we go. It's been recorded. So I go again, file, import, Excel spreadsheet, browse, and I'm gonna be using which data? Macro data. It's exchange rate, oil income, and money supply. So the first thing, in order to run the VAR model, as we have mentioned last time, you need to be sure about the data, whether the data is stationary or not. And the stationarity of the data means in the long run, they've got some co-integration. They have got some relationship long run. And that will make your data or result or the outcome from that you're going to be getting from the analysis more unbiased, more accurate, we can say. So first of all, you have to declare data set to be time series because we are dealing with the time series data. So it's basically TC set you select years, and it's going to be yearly. Okay. This is set, gonna be yearly. That's okay. Now again, we move to the second step to see whether data is stationary or not. We're checking for stationarity using one of the methods which are available, like Decay-Fuller method, one of the popular and one of the famous methods that are used generally. So we're going to be using this D-Fuller, and you put the variable that you're going to be dealing with. Let us just identify. Let me this time go with exchange rate and the oil income. Okay, the income from the oil, okay, as a percentage of the GDP. So I will go with exchange. So are you all with me?
Yes.
Okay. The result shows, if you look to the p-value, to the last line that we have it here, the p-value is showing that it is more than 1 or 5 or 10% of level significance. That tells us that the data or the variable is not stationary. We need to convert into stationary. Well, because these type of things has got some trends. So when there is a trend, when there is some patterns of the non-stationarity, that means the result that you're going to be getting, it's not going to be valid. So let's start and get the differences, or first we can get the log actually. So gen, I will call L exchange, okay? Logarithm of exchange equal to logarithm of exchange. So what I'm doing here, after generate, I create a name of variable, which is L exchange equal to, and then I'm given the function. Take the logarithm of exchange variable. And once it will be taken and it will be stored as L exchange. So we will see that there will be a variable appeared as L exchange. So on the right side on the box, we can see L exchange appeared. Then we move to the second step of the analysis. It's basically, we need to take the differences. Differences will allow us to convert the data. Did someone say anything? Let me check. Okay. So differences will allow us to convert the variable into stationarity. And basically it removes the trends if there is a trend. Again, generate. I'm gonna put the name that I will be using. I'll just call like X with a capital letter equal to difference of L exchange and multiplied by 100. So the X variable has been created here. Then I'm gonna do the same thing with oil income, okay? Here, this I'll put like L oil logarithm of oil. And the last one, I will take the differences. I'll call as income, just income. Just let me call it as an income. And I will just replace this by L oil. So income in here is proxied as income from the oil, which is logarithm, and difference was taken to by multiplied by 100. So now we have created logarithm variables, and then we took the differences that should have helped us to solve the problem of stationarity. Now, in here, for example, not to be kind of confused, I can drop some variables, which I don't need it. I can drop it. Okay, I'll drop this all variables, and I have like exchange and income only that I will be dealing with only. Now, I will again take the decay fuller with exchange. So as you can see, the p-value is 0. That shows it purely became stationary. And decay fuller of income. And again, it's stationary. The values are stationary. Now our variables are ready for it. The second thing that we need to go with, it's basically, we need to understand to run the model with a certain lag values, okay? And I will just try to estimate the VAR model, vector autoregression model. I'll just type VAR, put the variables, put the lags let's say from 1 to 2, just 2 years. And I can run. So here I've got the following information. So on exchange, I'm trying to see how the values are having the impact. The lag of the exchange of 1 has got no impact. It's not significant in L1, L2, but lag of the income, the first lag of the income is significant and it's negative. So it means that exchange rate will increase as the income from rent will go down. Increase of the exchange rate means what? Decrease of the value of the domestic currency. The domestic currency is depreciating. That's what it tells us. And income is affected by exchange from the second lag and affected from the lag of second year from the income. Like 2 years reduction in income will have a negative impact on today's income. So kind of there is a persistence of 2 years. However, how many lags we have to use here? Only if we run VAR model, that will help us to understand and to select the optimal lag selection. VAR, and it will give us the optimal, where the Schwartz, Akaike, and Han and Quinn will tell us what to select. Again, as before, it says 0 lag to use it. So Akaike, Han and Quinn, and Schwartz suggest to use 0 lag. And on the other side, we need to check whether the model is stable or not. We need to run the VAR stability, okay, VAR stable. Just run after it, VAR stable. And again, all eigenvalues lie inside the unit circle, so VAR satisfies the stability condition. Do you have any questions?
Just have other numbers
Where?
everywhere.
Wait a second. Did you do the logarithm? Did you take the differences? And when you put the VAR model, which variables are you using?
X and E for you.
New one. The last one that you have generated, yeah? Okay. Then let's see whether the behavior of, or before going to the behavior, or let's see the behavior too. Let's see the behavior of variables, if it's normally behaved, normally distributed or not. First of all, we need to predict the errors. Predict error, residual. Okay. And summarize error. And then you put into graph. Guys, let me know if I'm fast. I will slow down. So these three things that we're doing, we created error disturbance, and then we summarize it, and then we take the average or the mean value of the error and put it into the graph. If in the graph it will go around the mean, then it has a normal behavior. If not, then there's a problem. So as you can see, it goes around the mean, but in some cases it varies a lot. So do you want me to repeat? Please don't hesitate and tell straightforward. We're using the macro data. Did you open computer? Okay, macro data, it's available on L drive. Last time we did it. Just import and do the following. In case the video is being recorded, I will share the video with you so you can rewatch it again. Okay, we have seen that it follows the normal distribution, and let's do autocorrelation test. We can see that there is no autocorrelation in all lags. Guys, again, this optimal lag selection, it doesn't necessarily mean that you have to use it. It's just a recommendation. If you don't use it, it's up to you. But the most important thing that if you use, let's say, 2 lags, you have to be sure that there is no autocorrelation in one of the lags. Okay? If this Lagrange multiplier has shown that one of the values are significant, then you would have ended up like, don't use certain lag because there is autocorrelation in that lag. Let's say they found that this is significant, then you don't use this lag. You will use up to 1 lag because there is autocorrelation. But in this case, there are 2 lags, and they're both, they don't have like autocorrelation.
They will have autocorrelation. It is in the range of 1, 5, 10, right?
Yeah. Let's say you found the autocorrelation to be here, so it is the best to use only 1 lag in your VAR model and explain the VAR model of 1 lag. Don't use all lags because in the remaining lags there will be kind of autocorrelation. Okay. Now, next, you can use Granger causality to see what causes what affects what mostly. It's like VAR Granger. In here, we can see that none of them are significant. But in the previous case, we saw that money supply has got impact. So the exchange rate has got the impact on the money supply. So exchange rate Granger causes money supply. But in this case, none of it. Neither exchange nor income. And then we move to create the impulse response function. And you know what is the impulse response? It's you create the shock of one variable, and that shock, how another variable responds to a certain shock that you have created. Your exchange rate suddenly changed, how your income on oil will change. Okay. Now, to do that, it's basically IRF set IRF. IRF refers to impulse response function. Impulse response function. So now it's an archive, then you have to IRF, create IRF 1. Okay, I will name it as 1. IRF 1. And step, it's basically you're telling how many steps it should take forward to predict in what direction it will go. Let's take 16. It could be 10, it could be 15. Oops, sorry. Let me IRF. Okay. I created with a capital letter. So what I did it, I just created IRF, just wrote it as a capital letter. IRF 1, it doesn't recognize it, okay? It doesn't recognize it. So go with this, just IRF with a capital letter. Okay. Then put into graph IRF graph IRF impulse response. Here I'm gonna put exchange and income. Here I'm gonna put exchange and income. Okay. So here we can see here, okay? Look at here. Shock in income from the oil doesn't have any impact on exchange rate. So if suddenly the income from oil will change, increase or decrease, it will not have any impact, we can say, on exchange rate. The exchange rate will respond like with a stable manner, as you can see here. Look at here. A shock, let's say, the income has substantially increased. Exchange will slightly go down, very small amount will be changed, but again, it will come to its like equilibrium. So it's a normal way of corridor that it used to go. So basically in Kazakhstan, exchange rate is not affected by income of oil. That's what the picture says. That's what the result says. We need to investigate more further, okay? But this is like first impression we get it. But from the previous example that we used to try to understand, money supply has got the impact on the exchange rate, and exchange rate has got the impact. So as a suggestion you can make here, government should not rely on income from the oil and should not take into the account thinking that it will have an impact on the exchange rate. It will not in this case, because the shock changes in the income from the oil wouldn't have that much impact. But when it comes to shock in exchange, like sudden increase of exchange rate in the country will, first of all, drop the income. Let's say in 1 year, the income from the oil will go down and then go up. in 1 year, another 2 years, and in the 3rd year, 4th year, it will go down, and then it will be stabilized. Okay. So there's a sudden response of the income from the rents, income from the oil, to a shock of exchange rate increase. Okay. Do you have questions? Yes, please. To explain what? VAR model. VAR Granger. Okay, VAR Granger shows what causes what, like Granger causality, okay? We have seen here the income does not cause exchange rate, and the exchange rate does not cause the income. That's what we have seen it. But last time what we did it, for example, let's go with what we have. Yeah, they are not significant. They are not significant here. They are not significant at all, the p-values. If they were significant, then we would say that income grandeur causes exchange rate, and exchange rate grandeur causes income. But in both cases, so basically this model cannot be used to explain a proper relationship. However, when it comes to the impulse response function, it tells us that only sudden changes in exchange rate has got the impact on the income from the oil. But the vice versa, it doesn't work. It works, but very, very low amount of the impact on that. But let me try another one. I will use another data set. Okay, I will use for the US case, okay, United States. Domestic credit, export, FDI, GDP, military expenditure, and so on. Okay. Okay. Oops, I imported the wrong data. Now just fabricate the data and make it longer. Okay, perfectos. Now again, going here. Do I have any other data here? No. Why it's like seconds? Again, it sees those. Okay, anyway. Okay, it doesn't see all the values. Okay, we imported. Then I'm just declaring the dataset to be time series. Okay. And we have domestic credit, we have export, FDI, GDP. Okay, let me use FDI and GDP. Okay, I will use the FDI and GDP. I want to see the relationship of FDI. Does the GDP affects the FDI or FDI affects the GDP? Let's see. So let me go with a decay fuller of GDP. So as you can see, it's not stationary. I'm gonna go with a decay fuller again, but for FDI. Again, slightly stationary. Now I will take the differences and I'll take the logarithm first. Generate LGDP log of GDP. Again, generate just with a small letter GDP. Now this time, difference of actually I already taken before the logarithm of GDP. Anyway, LGDP and multiply 100. The same thing I'm gonna be doing for FDI, LFDI. And differences with a small letter FDI. Now, two values has been created that I needed, so I will drop the rest. I don't need these values for now, and the rest I will drop it. Yes. Now I need GDP and FDI. So if I'm gonna be using decay fuller, yes. No. I created the values that I needed, like differences. I took the differences of logarithm GDP.
Okay.
I create the final value to be sure that my data will be stationary. So it's stationary and FDI is stationary. Now we can run VAR model of GDP and FDI. We somehow see that in the VAR model, FDI doesn't have any impact on the GDP, but the lag of the previous year of the GDP has got impact on the current GDP. And GDP doesn't have the impact on FDI somehow. And on the other side, the previous lags of FDI has got the impact on the current lag, on the current FDI. So let's see the optimal lag selection here. Look, very interesting. Phillips-Perron tells you to use lag 2 lags. But wait a second. Yeah, 2 lags. And Akaiki tells you to use the lag 2. Hannon Quinn and Schwartz criterion, they tell you to use lag 1. So in here, I would suggest to go with the recommendation of Akaiki. Like many scholars, they say the most accurate is given Akaiki, like based on the research. But anyway, it's up to you. If you select like Hannon Quinn or Schwartz criterion, then you go with that because it has been recommended. So let us go with with 2 lags, okay? Like 2 lags are okay. Then we check for stability, VAR step, stable. We can see that all the nodulus are less than 1. All the eigenvalues, they lie inside the unit circle. So VAR satisfies the stability condition. VAR mal, which means to check for autocorrelation. VAR mar. Yeah. And we can see there is no autocorrelation within this model. Perfect. And let's see the behavior. predict error residual and summarize error and GC line error get this mean value and put it here. So the model seems okay, but in the last year, because we fabricated, there's a problem. But if we didn't fabricate, maybe the model would be nice. But we have changed the model, unfortunately. Yeah. Anyway. So behave normally. Let's see the Granger causality. VAR Granger. Again, from the Granger causality, we see that neither GDP nor FDI has got the impact. Granger causality. And the last one we go with impulse response function. IRF set IRF. Then IRF create with a capital letter IRF and step, let's say 10 for 10 years. Okay, we have already created. Let me just put one here then. Okay. So I have to close down my state and run it again, then it will allow me because it has already been created before, so I cannot use it. So IRF with a capital letter and 1. And then I just put all the values with the IRF here, like IRF and IRF here and 1. GDP and FDI. GDP and FDI. Now, as you can see here, FDI and GDP. So the shock of the FDI, immediately, let's say there's a sudden increase of the foreign direct investment in the country, would not have any impact on GDP at all. Like the GDP will not be kind of responded like quickly, like it as it was. No problem, come and invest. Why? It is like logical. The country already has been developed, it's already growing, and it's not growing because of the foreign investments. Because it has its own capability, its own capacity to grow. This could be a logical explanation. But if GDP changes suddenly, the FDI, the foreign direct investors, will respond. Let's say, if the GDP increased suddenly, FDI goes down. And then later it gets up and down and it gets into, but it will take, to get into the stable behavior, it will take 5 years. It will not kind of converge into the long run equilibrium immediately. It will take 5 years if the GDP suddenly changes. Okay. And actually, we can see that it has a negative, then positive. Okay. Any question? Will you be able to do it in the quiz? Why not? Okay, now there is an activity 7. Open your data and select any 2 variables from the US, which is there already, 365, and test it. Everything what we did in the class. No explanation, just get the results and upload it to the Moodle.
Should we fabricate it as you did?
No need. No need. Or it's 362, whatever. I might be mistaken with the numbers. But don't take the GDP and FDI. Select some other variable. There are many other variables. Just try it that it should work with you. If you have any question, just call me. Let me stop it. This one. I'll stop recording.